You are welcome to another section on spectroscopic technique. In this section, I will be talking about wavelength and wave number. Why are these two quantities very important? They are very important because we are going to need them in subsequent topics we are going to consider under spectroscopic technique. For example, in UV spectroscopy, the major quantity of which is of very importance is this. The absorption in UV spectroscopy has to do with wavelength, but in IR spectroscopy, in the other hand, you have to be using the wave number. So we have to have a little understanding about these two particular quantities. So in this video, I want to just share with us the length between the two of them and also give us some examples or calculation that has to do with the two of them. So to start with, wavelength is usually denoted by lambda, while wave number is denoted by this. Now, the relationship between the two of them is that they are reciprocal of one and another. So which implies that wavelength is equals to 1 over wave number. That is lambda equals to 1 over v bar. So this is the relationship between these two quantities in the sense that your wavelength is reciprocal of wave number. At the same time, from this expression, we can also bring out that wavelength is inversely proportional to wave number, which implies that as one increases, the other decreases, which is also vice versa. Now, the next thing I also want to talk about is about their units. Most times you see your wavelength given in nanometer. But for wave number, it is usually given in per centimeter. So these two are this is the unit for wavelength and this is the unit for wave number. So, and let me say these are the basic things that we have to know about this particular two quantities of importance for our spectroscopic techniques that we are going to be other topics we are going to be looking at in spectroscopic technique. Now we want to talk about an example on wavelength. We want to look at an example at the same time calculation of wavelength and wave number. In this particular example, the wavelength of a light ray is 500 nanometer and we have to find the wave number. Now, to make it quick, one simple way by which you can just quickly get this is by changing the wavelength given to us, which is in nanometer to meter, and from wavelength in meter, you use it to get a what? You convert it to centimeter. At the same time, use the wavelength centimeter to get the wave number. So let's follow. So the first thing is that I will try to convert my 500 nanometer to meter. Nano means 10 raised to power minus 9. So that means I will say that 500 nanometer will be equals to 500 times 10 raised to power minus 9 meter. Now, why do I have to go this way? It's just for us to also have an idea about conversion. Now that I got my wavelength in meter, I can also do it to convert the wavelength in meter to centimeter, because we know that 100 centimeter makes 1 meter, and that implies that 500 times 10 to the power minus 9 meter will be equals to 500 times 10 to the power minus 7 centimeter. How do I? Because if I have 1 meter, I just have to multiply it with 100 to get the same thing, the same value in what? In centimeter. So 500 times 10 to the power minus 9 multiplied by 100 will give us 500 times 10 to the power minus 7 in centimeter. And the last thing to do is now to use your formula, which is that lambda equals to 1 over v bar, which we can also say that the wave number equals to 1 over lambda. Now that we have our lambda in Now that we have our lambda in centimeter, then we can say that V bar equals to 1/500 times 10 to the power minus 7 in centimeter. So that by the time I get my wave number, the unit will just be directly what in per centimeter. Therefore, my V in this place will be equals to 1/5 times 10 to the power minus 5, which will be equals to 0.2 times 10 to the power minus 4 times 10 to the power 5, and that will be equals to 2 times 10 to the power 4 per centimeter. So that implies that 500 nanometer is also the same thing as 2 times 10 to the power 4 per centimeter in terms of wave number. And that is just a simple way of getting your wave number when you are given the wavelength. I believe that from this lesson you'll be able to catch one or two things, and I want you to give your comments, drop your questions. You can also share with friends who this particular topic can also be of great help to. Thank you for watching. I hope that you watch, share, like, and sometimes subscribe. Thank you.